Hi there, Year 4. This is our second science lesson for this week, and it is still about sound. The learning objective is I can recognize that vibrations from sounds travel through a medium to the ear. And we'll go through some of the vocabulary so that we can understand that learning objective a bit better. Before we look at the key vocabulary, let's have a quick recap. What did we learn about last lesson? Sounds are vibrations. The vibrations travel as sound waves. And then we can see in the picture that the hand is tapping the drum and the drum skin is vibrating, causing a sound and making everything around it also vibrate. So the vibrations cause the particles around the vibrating source. Now the source is where something has started. So it has started at this drum skin and it's everything else is starting to vibrate. And this in turn vibrates other particles, sending a ripple away from the vibrating sound source and goes into the ear. Okay, key vocabulary. First one is sound. That means a noise. And the word transmit means to transfer. Medium. Now, this is a tricky one. This one means it's the in between substance that actual forces are transmitted. So, if I threw a ball from one person to another, the medium it is going through is the air, which is gas. Air is the invisible gases surrounding the earth. Water is the liquid moving around the earth in the water cycle. Solid is a state of matter where they keep their shape, they can be held, and you can cut them. Vibrations, they're occurrences or things that happen with quick movements to and fro. The source is a place where something starts. Sound waves are vibrations that you can hear. Particles are tiny bits of matter. And travel is journey from one place to another. Can you hear through the medium of solid? Have a think. If someone's knocking at the door and you're on the other side, can you still hear the sound? If you're wearing a woolly hat that's covering your ears and someone is talking to you, can you still hear them through the hat? Yes, you can. You've got a solid which is made up of lots of particles which carry on the vibrations and pass them to all of the particles close to them. So they would then transfer into the air through into your ear. Now have a think. Can you hear through the medium of liquid? When you're in the swimming pool and you've got your head underneath the water, can you still hear someone that's talking that's out of the pool? If you're in the bath, then you've got your ears under the water, and then someone walks in and starts talking to you. Can you still hear them? Yes, you can, because liquids are made up of lots of particles, and those particles are transferring the sound energy, the sound waves, and passing them further on until it gets into your ears. Can you hear through the medium of gas? Now we know that air is gas and that's all around us. You wouldn't be able to hear me now if it wasn't for the medium of gas, because the particles of air are carrying on the vibrations and transmitting the sound waves into your ear. Now, remember what I said in the lesson last week when we were talking about the Mars landing? In outer space, there are no particles, there's nothing in outer space. So you can't hear anything out of space because there's nothing, no particles to vibrate the sound on. Activity 1 is using gas as a medium. You need to go outside with this and you need to have a wooden spoon and a saucepan. And you need to take someone with you, either mum, dad, or brother, sister. So you give the wooden spoon and the saucepan to your partner and you stand 10 meters away. You ask your partner to bang that wooden spoon on the saucepan. Can you hear the sound? Ask your partner to move a further 10 meters away and get them to bang the spoon on the saucepan again with the same force. Not harder, not lighter, it needs to be the same force. Can you still hear the sound? Ask your partner to move a further 10 meters away. Bang the spoon on the pan again with the same force. Can you still hear the sound? You'll notice that you might notice that further away, you might see your partner bang the spoon on the saucepan, but you won't hear it at the same time. You might hear it after. So your activity is to do this, and then afterwards you need to write how does that sound from the spoon banging on the pan travel to your ears? What particles has it gone through, vibrated through? Where has the sound waves gone through? Activity 2 is using liquid as a medium. So I want you to think about a time that you've been swimming or had a bath and your ears have been under the water. Someone's come to speak to you, but you still heard them. So I want you to describe how that sound travelled from that person's mouth through to your ears. What particles did the sound waves vibrate on to get to your ears? So activity 3 is using solid as a medium. Put your ear to the table. Ask someone to scratch underneath the table, maybe at the other end of the table, and then tell them how many times that they've scratched. My children did this the other day and they were blown away with the noise. Next, put your ear to the door. Ask someone to stand on the other side and knock. And tell them how many times that they've knocked. So, I want you to think about how that sound got from the knock. What was the first thing that's vibrating? How did it get through to your ear? So have a think. How did that sound wave travel in through to your ear? The extension for today is which one of these states of matter, the solid, liquid, or gas, transmitted the sound waves the strongest, and why do you think this is? Now, this is an important question, and you need to think about the way the particles are in solids, liquids, and gases to answer this question. We have two optional investigations, okay? One of them is a string telephone, and you'll need a paper or a plastic cup or a yogurt pot and long lengths of string or wool. And what you do is you make a hole in the bottom of the two cups, thread one end of a long piece of string through the hole and tie a knot at the end with the knot inside the cup. You can use some sellotape to stick that down inside the cup. You thread the other end through the hole in the second cup and tie a knot at the end there. You give your partner one cup and hold one cup securely. Walk away from each other until each string is quite taut, and that means when the string is tight, so that the string line is really straight and tight. So speak, I might even whisper actually. Don't shout into the cup while your partner holds his or her cup to their ears and listens. When you finish your message, you say the word over. Swap over so that you can now hold the cup to your ear while your partner speaks into their cup, finishing with the word over. Now, the questions I'd like you to answer if you're doing the string telephone optional investigation are: try repeating the conversation at the same distance without the telephone. Is it easier to hear with or without the string telephone? Now, remember, don't shout, keep it at the same level. You need to have your voice at the same level. So if you're going to whisper in the string telephone, whisper the conversation at the same distance. Can you make your string telephone work around a corner? What happens if you tie a knot in the middle of your piece of string? Why do you think this happens? Write down any differences in sound when the string is tight compared with it's loose. So instead of having the string in a straight line in the middle, make it dip so it's all baggy. See if there's any difference. You could undo one knot in the cup, cut the string in half, and then reattach the second cup. And then see, does a shorter string make any difference to the sound? And then the last thing I'd like you to do is write a short explanation of how the string telephone works. How does the sound transmit from the mouth to the cup to the other person's ear? And the optional investigation number 2 is making gong ears. And you'll need scissors, string, and a metal coat hanger. And if you haven't got one of those, you can always use a metal spoon. So you need to cut around about 50 centimeters length of string, 2 sets. And it doesn't have to be exactly 50 centimeters. And you need to tie one to each corner of the coat hanger. And make sure you do the knots quite tight, otherwise they slip and slide. You wrap the other end of each string around your finger. And I would first of all gently tap the coat hanger against a table or a chair and listen to the sound that it makes so that you can hear it first without putting your fingers in your ears. Then put your fingers in your ears. Don't do it too hard. And then do the same tap of the coat hanger, but with your fingers which are wrapped with the string, and put them in your ears. And what do you hear? And then what you can do is you could maybe swap the metal coat hanger for things made of different materials, so plastic or paper. If you are doing the gong ears investigation, I'd like you to answer these questions. Why does it sound so different when you put your fingers in your ears? Think about the states of matter and the particles. Where do you think the sound is coming from? And how does it reach your ears? Try using a longer or a shorter bit of string. Does the sound change? If you've got it lying around, use some wool or ribbon instead of string. Does that change the sound? Maybe try replacing the metal coat hanger with a different material. A plastic coat hanger. Some paper. Did they make a difference? Have fun investigating!